Welcome to a Rocscience feature video. Here, we will be discussing RS3 and Slide3's ability to import pore water pressure data to perform slope stability analyses. In this video, we will import pore water pressure data from RS3 to perform the slope stability analysis in Slide3. We begin in RS3 with a pre-built model of a transient dam that has been converted into a mesh and will be computed. We first save the compute file. Then, navigate to the Compute tab and select Compute Groundwater Only. The engine will pop up and compute the results. In the Results Workflow tab, we will click Interpret, followed by Refresh Results. Under Data Type, we'll click Total Pore Water Pressure. Here, you will be able to see the results of the transient analysis of the dam. You will notice that these pore water contours in each stage are showing the distribution of pore water pressure at different times, stage 1 being a day, stage 2 after 5 days, stage 3 after 10, stage 4 after a month, and stage 5 after a year. Now that we've generated results, we will proceed to export the pore water pressure in a format to be read by Slide3. You may select whichever stage it is you would like to export data from. For this demonstration, we'll be exporting stage 3. To do this, we'll go to File, Export, Export Pore Water Pressure to Slide3. This file will be saved as follows, so that the data will be extracted to a comma-separated text file. We'll be using Slide3 for the remainder of this video. We've opened the Slide3 model file that has the relevant project settings and material properties, and have saved it as a Slide3 file. There are some changes we will make prior to importing the PWP3 file. Opening the project settings, we'll select groundwater and change the default groundwater method to water grids, then click OK. We are now ready to import the PWP3 file. We'll first select the groundwater tab, and then navigate to the groundwater menu and select Add Water Pressure Grid. We'll then click Import and import the PWP3 file. The following water grid should be added to the visibility pane. We'll now assign a water grid to our model. The water grid depicts the pore water pressure at various locations throughout the model. We'll do this by going to the groundwater menu and clicking Assign Water to Materials and changing the water settings to Water Grid 1 in the top right of the dialog. The operation will be finished by selecting Apply to All Materials and clicking OK. You may notice that there is pore pressure greater than 0 on the right side of the model, indicating that ponded water exists on the upstream portion of the dam. We can define ponded water loads by adding water surfaces to the right side of the model. The ponded water load will be automatically calculated for a water surface above the ground surface, but not for water pressure grids with pore pressures greater than 0. To define ponded water loads, go to the Geometry tab and select the Draw Polyline tool. We'll select Plane Orientation YZ and then enter the necessary UV coordinates. Click the blue checkmark to close the pane. Selecting the new polyline, we'll navigate to the Extrude tool. We'll enter in an XYZ value of 100 with a depth of 400 and an offset of -20. The ponded water load will be fully defined once we select Add Water Surface via the Groundwater menu. Make sure to select the polyline as the surface. After clicking OK, the Hydraulic Assignments dialog will open. Since we would like the water grid to be used for pore pressure calculations in the soil, we'll select Cancel. The water surface will be used to only calculate the ponded water load above the ground surface. We are finally ready to compute. We've used the Yambu analysis method for this demonstration. The safety factor will be shown in the toolbar. To view data contours on the slip surface, select the Show Contours toolbar button. The default setting is Base Normal Stress Contours, the normal stress on the base of the columns. Select pore pressure contours and the results should look as followed. Thank you for watching our feature video. Please check our playlist for more videos and demos.